Hello and welcome to VEX Robotics for Competition, a tutorial for new teams, presented by McAllen Robotics of Austin, Texas, Team 8756. This program will cover time-based autonomous programming using functions. Previously, we've done autonomous programming using line-by-line instructions. That is, we give an instruction to each motor one line at a time. As we've done this program, we've seen that there's a lot of repeated calls, that we often ask all four drive motors to act together, and it would be great to consolidate those four lines into one statement, and we can do so using a void function. Functions will be placed up at the top of the program in the header, where you do things like assign variables and make definitions and have your functions. So we'll want to make a little space, and as we've done before, we'll want to write a comment line that describes what we want to do before we get to work. So we want to make a function to run drive motors at a specified speed. And we'll be using a void function. Functions can be used to return a value. A void function performs an action and doesn't return a value, therefore it's called a void function. So we type in void, and you'll see that RobotC recognizes it because it turns it into a colored text. And we want to give our function a name. Auto drive would be a good one. And then it'll have, in parentheses, a space where you can have it receive integers or any other C structure. So we're going to do an integer that's called speed, and then we'll have curly brackets, and like we saw when we were doing if statements to run buttons, whatever's inside these brackets will be run anytime the function named AutoDrive is called in our autonomous program. So we want it to run the drive motors. That's exactly this set of code. We want it to run these motors. So I can copy that and paste it into my void function. And we want it to run the motors at a speed that we tell it whenever we call this function, and that would be the speed. So I want to copy speed here in place of these 127s. And then we'll run the drive motors at speed. And that's our first function. So now, instead of having these four lines of code, we can just say auto drive and 127, and it will do exactly the same thing. Similarly, these are an auto drive. They're an auto drive that goes to 0 as opposed to a drive that goes to 127. So we don't really have to have a stop function. We can just say drive at 0 speed. So if I change this to that is the same as those four lines of code. And so you can see we've now reduced 9 lines of code to just 3. We can do the same thing for the flag twirler, but it wouldn't make a lot of sense given that it's really already one line of code. We would going from 3 lines to 3 lines. We can change this turn though. So this is a different drive function. We can't use auto drive because when you're sending a turn instruction, 2 of the motors are going positive and 2 are going negative. So we'll need a new function for turn. And we'll want that function to turn the robots at a specified So what we're going to need to clarify is what the speed is actually telling us in our function. Positive speed will turn right, and negative speed will turn left. So now we're going to do another void function. Auto turn would be wise, and we do want another speed value. Curly brackets. And we're going to do a similar thing to the drive, except for we want negative speed for the right motors. So if we give it a value of 80, it will turn to the right because the left motors are going 80 and the right motors are going negative 80. And if we give it a speed of negative 80, it will turn left because the left motors will be going negative 80 and the right motors will be going positive 80. So that will let us replace some lines of code down here. That replaces those 4 lines with 1. We have our weight staying in place, and then we will auto drive at 0. We don't need to auto turn at 0, although it would work. We just want to stop the motor. So auto drive 0 is like stop the drive motors. Looking down further, we can see, okay, this is our drive. We can change that with auto drive, but it needs to be at 90. And then we can get rid of these 3 lines. We need to make a function for our arm. So the arm is going to be a new function. So we want a function to run the arm motors at a specified, and we could say that positive speed lifts the arm and negative lowers the arm, and remind ourselves to remember gravity, because we have to remember that when we're setting values to raise and lower the arm. So our void function for there would be auto arm, and it would have an integer for speed. And we want to define the arm values there. So let me go look what that looks like. We'll take all these guys. Place them here. And remember, we want them to be at speed. Okay. And that would allow us to replace any call to the arm motors with void function auto arm. And these were at 127. That will run all 4 of the motors, so that takes away those 3 lines. Lift is like flag twirler. It only takes 1 line of code, so it doesn't help a lot to reduce it to a function. Here we have a drive stop and an arm stop. We need to remember our arm stops are going to be 20s, and then the lift stop. So we can replace our drive stop with auto drive 0. And we can replace our arm stop with auto arm 20 to hold for gravities. And then here we're twirling the flag. No reduction to use a function. Here we're driving at -90. So I remember, I believe this is wrong. If I remember, this is the same as this guy, but everything negative. So we'll copy this whole dude down to replace all this line of code. And we'll just invert these. So we did -90 drive. We need to do -80 for arm because we don't want it to slam down. The motor lift, we need to go -127. So weight is the same, 0.5 seconds. And the arm hold at 10, 20, just the same. So now we've reduced our code a pretty good amount. Let's download it and see if it does the same thing as our line by line did. Nested functions. It worked, and you can even tell it's different than the previous video because it's not crooked, and you can see the whole robot. So you might be thinking, well, great, that saved some lines of code, but it's still sort of long. It's more than a screen long. But we can reduce even more. So if you start looking, you'll see that we often call a drive, a wait, and a stop. So we could make a function that says drive, wait, and stop. We would need to send a speed variable, and we need to send a time variable. So I can go back up. I'm going to put this next to the auto drive instead of continuing at the bottom of my function list because they'll be connected. I'm going to make a function to drive at a specified speed for a specified time. And that won't be another void. And I will call it auto drive time. And I'll have two variables in there, speed, comma, and time. How about let's do msec so we know that we're always using milliseconds. Close my parentheses. Make my curly brackets. So one thing you can do is you could just have this motor function down in here, and this would be a little bit longer, but you can call a function from inside a function. So down in our autonomous program, we're going to change these three lines to auto drive time. That'll jump up here, run the code in here, and then this code will do an auto drive of 127, or sorry, speed. I have a semicolon, and then it will have a wait, 1 msec, for the number of msecs we tell it, semicolon, and then an auto drive of 0, semicolon. So this looks a lot like our three lines of code down here, because it is a lot like our three lines of code down here. We'll now be able to replace all of these with auto drive time, 127 for the speed, 1000 for the msecs. And since it's a nice neat line, I'm going to put the description after it. If I apply that same logic that I did to have a second function for drive, which is auto drive time that stops, I can do the same thing for auto turn time, where it calls auto turn and then stops, auto arm time, auto flag time. Didn't make sense to have an auto flag, but it does make sense to have an auto flag time and lift time. And then I can also make a function that I expect I might need, which is all stop, which will give me a stop for everything. And if I did that, then my auto drive, auto flag, and auto turn would replace the first 3 lines that I had before. And now I'm at the point where I want to do multiple things. And there's no limit to how many integers I can pass to a void function. So I can make a function that does everything. It'll take 6 variables, but that's okay. So I can go up, I can start making my final function, and it'll do everything at once. So we'll add another function, and it's going to be to run any and all of the motors for, well, at a specified speed for a specified msec. And this will requires 6 variables. If you're counting in your head, you're thinking, well, you really only need 5 because you got the drive, but you're going to have to give 2 different instructions to the drive so that you can turn, because you may want to drive forward and you may want to turn. So we need to give a variable for the left drive motors and a variable for the right drive motors. So this void is going to be auto everything, and it has time to it, so we'll put time in there so we know that. And it's going to have an integer for the left drive, integer for the right drive, an integer for the arm, an integer for the lift, but that's already defined as a motor name, so I'm going to give it another little bit so that it stays separate, and an integer for the flag, finally an integer for the number of msecs. So I'm actually going to go all the way down to motor values for the drive, or I could be more efficient and copy it from up here. Let's do that. So I'm going to get 4 lines of code for my drive, and it's going to be the left side will be assigned to left, and the right side will be assigned to right. Okay, so that takes care of driving and uses these 2 variables. So we could send it a positive left and a negative right to turn right. We could send it a 100 for left and a 60 for right to make it arc to the right. We have a lot of options there. The arm, I'm able to use my auto arm, and it will go at arm. And the lift speed, that's also a motor command. And it's set equal to lift speed. The flag is a motor command. Set to flag. And then I'll wait 1 msec for the msecs. And then I need to stop everything, and I can actually use my all stop command that I have, which sets my drive motor to 0, arm to 20, and the other 2 to 0. So all stop. And it doesn't need a variable. And then that's it. So now we go down here. We've got our complicated thing. So we're driving forward. So we want to say drive 90, so we remember what we're doing. Arm 127, lift 127 for 0.5 seconds. Alright, that looks like everything we need, and now we can just say auto everything time and put in our numbers. So we need a 90, a 127, a 0. Nope, lift is 127. A 0 for flag, and a 500 from MSEX. Piece of cake, right? So now this guy can go here. So, as I said many times, kind of confusing. So it may or may not be desirable to you, but it is possible. The point is that you can send very long strings of possible options to avoid so that it can do lots of things. I'll go ahead and replace the rest of this code. Well, it looks like this. So if I replaced everything, I get down to 6 lines for my 6 steps in my program. And each line I can write a short description of what it's doing. And this can be very useful when you're making multiple programs. So we've got a lot of text up here now, which is kind of cluttery, I suppose. But what if we ended up with 18 programs? Well, the 18 programs will be a lot shorter. And more importantly than that, we can start doing more complex things with our voids than just replacing lines of single line code. For example, say in the drive function, a lot of people will have an ease in and an ease out. So instead of going immediately to 127, which can jerk the robot forward and maybe tip it over, if depending on where the arm is or whatnot, you might have a little routine in here. It might even be a separate function that you call that eases it in. So it starts at a half speed and then eases up to full speed. And once again, if you added that code in there, then every single time it was called in all of your autonomous programs, it would do so. You wouldn't have to change every single autonomous program. So that's a little bit about the values of doing functions. It cleans up your actual autonomous programs by shortening them, and it lets you globally edit repeated actions to fine-tune them as you see the need for it. Thank you for watching.